Hi. So now in this video, what we are going to do is we are going to create a lottery decentralized application. So let us look what we are going to see in this lottery decentralized application. What are the technologies that we are going to use in order to create this lottery decentralized application? Now, in order to create a decentralized application, we are going to use three technologies. First will be the front end, which we will create with the help of React.js. Okay, if you do not know React.js, I will advise you to at least have some basic idea of React.js so that you can do this course. Then we are going to create a smart contract. The smart contract that we are going to create will be in Solidity programming language. Okay, and in this smart contract, we are going to write the logic for our smart contract. Now, since this front end is of a real world part and this smart contract is a part of our blockchain world, so we need to connect these two worlds, right? These two different worlds. And how we can connect these two different worlds? So in order to connect these two different worlds, we are going to use a library called web3.js, which will actually help us in order to connect this front end with this smart contract. Now, this is how the architecture of our decentralized application would look like. Okay, so first we will create the smart contract and then we will switch towards front end. Okay, the smart contract that we are going to create right in our system, we are going to deploy this smart contract over Gorilla test network. What is a test network? So test network is a place where we are going to deploy our smart contract. Okay, so we do not need to pay whatever we have to pay for deploying our smart contract will be in terms of fake ethers. So we do not need to pay anything from our pocket and we can simply deploy and test our smart contract. Now, how we are going to talk to this Gorilla test network, because this test network is a part of our blockchain world and we are here, right? So how we are going to make a communication with this Gorilla test network? Now, in order to do this communication, we are going to use Alchemy. Now, this Alchemy will act as a bridge between our smart contract, or I will say between our system and this Gorilla test network, so that we can talk to this Gorilla test network. So if we will not have Alchemy, then we will not be able to talk to this Gorilla test network. Okay, so for that we are going to use Alchemy, which will actually help us in order to communicate with this Gorilla test network and in order to deploy our smart contract over this Gorilla test network. Definitely there are other uses of Alchemy as well. I will share the link in the description of the video, you can check out, but this is one of the use that we are going to see when we are going to deploy our smart contract. Now let's talk about the algorithm of our lottery application. So first of all, definitely we are going to create a smart contract, and this smart contract will be handled by the manager. So there will be a person who will deploy this smart contract, and this person will actually handle, or I will say control, this smart contract. Now, in order to participate into this lottery, definitely we need some people, right? We need participants. So these participants, in order to participate in this lottery smart contract, I will say lottery application, they need to pay a certain amount of fees. So let's say if the participation fees is 1 ether, so they will pay 1 ether to this lottery smart contract so that they can participate in this lottery. Now, once they have participated in this lottery, this manager, the manager of our contract, will call a function called pick winner. But in order to call this pick winner function, there will be a condition that there should be at least 3 people who are actually participating in this lottery. So that is the criteria that we are going to have. Definitely you can change it also, but in our lottery smart contract that I am going to create, I am going to have this criteria that at least 3 people must be there in order to call this pick winner function, which will randomly select one of the participants from the people who have actually participated in this lottery, and then whosoever will win, whosoever name will come in this pick winner function, that person will be awarded with the ether. So let's say if 3 people have participated in this lottery, so we will have a balance of 3 ether, and let's say one of the people from these 3 participants win, so this 3 ether balance will be transferred from smart contract balance to the person who has actually won this lottery. So this is how our lottery algorithm will work. Let's start with our decentralized application. So in order to create our smart contract, we are going to use Remix ID. And the reason for using Remix ID is very simple, because it provides us with an interface with the help of which we can easily test our smart contract. After testing our smart contract, whether it is working in a correct way or not, then we will copy paste our smart contract to our Visual Studio Code, and then we will deploy it to the blockchain. Okay, so for now, let us create our smart contract in our remix ID so that we can check whether it is working or not. So the first thing, as we discussed in the algorithm, is that we will have players, and the players will be of payable in nature. Reason being because we want to transfer, because they want to transfer and they want to receive some ether, right? And for that we need payable keyword. And I have discussed all these things in my Solidity course. If you haven't watched it, please watch it. I will share the link in the description. Then public, okay, so it is payable and public players. So this will be our players array, which is payable in nature. Then we will require our manager, okay, and then we will require the winner. So we will also make it payable because winner will be receiving some amount right after the after he will won. So that's why he must be payable so that he can receive some ether. And then we will have a constructor which will actually have our manager, right? So the person who will be deploying our smart contract will become the manager of our smart contract. Okay, so message.sender will be having the address, and then when he will deploy, then message.sender will contain the address of the person who is deploying the smart contract. Then we need a function with the help of which we can receive ether, right? And for that we will have our receive function. With the help of this we will receive ether from the players so that they can participate in the lottery, right? So payable, and for the participation let us have some fees, and I will have a fees of, let's say, 0.1 ether, or let's say 1 ether. Okay, it will be more easy. So let's say the fees in order to participate in the lottery is 1 ether, and if they are not able to pay this, then we are going to print statement that please pay 1 ether only. Okay, and if they will pay 1 ether, they will be able to participate in the lottery. And then we will have our players dot push. So we will, the person who is actually participating in the lottery, we need to have his address, right, or his or her address, so that we can transfer the money to his account, his or her account, when he will win the lottery. So payable, so I'm forcibly means I'm explicitly converting our message.sender into payable so that he can receive the amount. Okay, I think we have made some mistake. Okay, I think there should be 2 equal to's, right? Okay, now it is good. So if message.value is equal to 1 ether, then we will go to this statement. Otherwise it will throw an error that please pay 1 ether only, right? Then now we can create one more function with the help of which we can determine the balance of our smart contract. So when players will be sending the ethers, this ether will get transferred to our contract balance only, right? So let us create a function so that we can also see like what is the balance of our smart contract. So balance, and then public view returns. In this I will have uint because balance is in uint. Then require, and I will make sure that this get balance function can only be called by the manager of our smart contract. So I will check whether manager is calling this function or not. Message.sender. If manager is calling this function, then it's good. Otherwise we are going to throw an error that you are not the manager, right? And then we will return the balance of our smart contract. So to return the balance of our smart contract, I'm doing address this dot balance. This means this smart contract balance. Okay, and with the help of this we can easily determine the balance of our smart contract, and we will check all these functionalities. Okay, don't worry, we are going to check all these functionalities. Let us complete this smart contract and then we will see that. Now comes the important part, because this is a lottery, right? And in a lottery, each and everything, like the winner is determined in a random way. So we need to create a function which can randomly select the player. So I will create one function, that is random function, which will actually provide us with a random number. So I can have this as an internal function so that nobody can use it. Only it can be used within the function, within the smart contract only. And just one warning, guys, just one warning. Do not try to use this random function that I'm using here in your actual decentralized application. This is just a demo smart contract, right? So if you are going to use a smart contract where you want to generate a random number, there are other ways to generate that. In this, I'm generating it just to demonstrate you something, but do not use it in a real life fashion. Otherwise, you might get into trouble because this random function might not work all the time. Okay. So I'm going to return, and in this, what I'm going to do is, let me do that first of all. First of all, I'm going to do ABI encoding of our certain things. Like I will take block dot difficulty. Now just think of it as a way to generate random number. Okay. If you are not able to understand this syntax, just don't worry. This is just a syntax to generate random number. For now, just understand like that. Players.length. So players is our array, right? Players.length. Then we will take the hash of this ABI encoding. So I will do kcat 256 algorithm, and I will do this. Okay. After doing this, then I will return the uint part of our kcat 256 algorithm, and then I will return this. So this will actually return us with a random number. So this statement that I have written will actually give us a random number. Then we are going to use this random number, in order to pick the winner. So let us create one more function by the name of pick winner. In this we will have public. Then we will make sure that this pick winner function can only be called by the manager of our smart contract. So message.sender should be equal to the manager. Otherwise, we are going to print that you are not the manager. Okay. And then we can have other require statement, which will make sure that this pick winner function can only be called when the number of participants is greater than or equal to 3, right? This is what we discussed in the algorithm also. And if it is not the case, in that case, we will print that or throw an error that players are less than 3, right? And then we will call our random function so that we can have our random number. Okay. And then we will use this random number to find the index of an array. How? We will simply take this random number, we will take m% of it. So m% of this by players.length. So if you know that this m% actually provide us with the remainder. So if r is, let's say, for example, if r is, let's say, 100, and if you are going to do it m% 3, so this will return us with 1, because if you will divide 100 by 3, it will give you a remainder of 1. Or if, let's say, r is, let's say, 24, in this case, if you are going to do m% 3, considering that players.length is equal to 3, definitely if it is more, then definitely we are going to do that. But currently I'm assuming that the players.length is equal to 3. So I will take 3, and if you will do calculation, so 3 into 8 is equal to 24, right? So the remainder will be 0. So this m% will return us with all the remainder, and those remainder will always be less than equal to players.length. Means the remainder that we will get by doing this m% will be less than players.length. Okay, so if players.length is 3, then the remainder will be 0, 1 or 2. So remainder cannot be 3. Okay, because this is how this m% works. Okay, so the remainder that you will get will always be less than the players.length. So this will make sure that we are selecting index of an array, right? We are not selecting an element, we are actually having the index of an array, and with the help of that index we will determine the winner of this lottery, right? And then we will pick the winner. How? Simply, now we have the address, a random address, so we will take index, and by this we will have the winner. And after this, when we will have the winner, we will transfer the amount, transfer get balance. So this get balance will actually return us the amount, right? Because as you remember, this get balance function was returning as the contract balance. So when players will deposit their ether to this contract balance, we will have a balance of our smart contract, right? And we are going to transfer the whole amount to the winner of our lottery, and then we will empty the array, right? So that we can restart our this lottery. So I will make this array empty, and by this syntax you can make an array empty. Okay, so like this. Done. Okay, I think I've made some mistake here, so let me see what's the mistake. Okay, I think the spelling mistake is right, so length should be length, right? So now we have the pick winner function. We will create one more function, because this function will be very helpful when when we will create our decentralized application. Because we will create our decentralized application, I know I'm just going VV, but you understand, right? So when we will create our decentralized application, we can have the list of all our players. So for that I am creating one more function, that will be all players function, which will actually help us in determining who are the people who are actually participating in this lottery. So view returns, then address, payable, memory, right? Because we are talking about array, and that's why we have to use this memory keyword, and this will return us with all the people who are actually participating in the lottery. So now our smart contract is totally ready. Now let us check it whether it is working in a correct way or not. And in order to check it, we will simply go and deploy it to our local environment, to this remix ID environment. So since this address is going to deploy this smart contract, he will be the manager. So I'm deploying this. So now we have our lottery smart contract. Now currently, if you will see the balance of our smart contract, it is 0, right? And we have no players who has participated in this lottery. So I will change this account, and I will transfer some ether. So I will take one, I will change this to ether, and then I will go down and I will click on, okay, I'm not seeing, okay, okay, I think yes, actually we have made this function a receive function, right? So we do not need a function, right? We can simply go and transact the amount. So simply transact, and you can see that, right? This amount is transact, and we can see all players. So you can see that currently we have this address AB8 who has participated in the lottery. You can also see the players array also. So I will do index 0. So you can see that. And then again, we will take some other address, because we need at least 3 people, right? So this address, again, 1 ether, and then again we will do transact. Now let us check whether we have all players or not. So you can see that we have another address also here. Let's do that for another address, and you can clearly see that all the balances are being detected, right? 1 ether is being detected from all these accounts because they are participating in the lottery. So let us go down again, 1 ether, and then we will do again here transact again. Now we can see that we have the this address also, this address also participating in the lottery. So now we have at least 3 people who are actually participating in the lottery, right? Now the manager can call this pick winner function. Currently, if you will see, we do not have any winners, and if you will check the balance of our smart contract, okay, I think we are not the manager. So you clearly see that you are not the manager, and only manager can call this get balance function, right? So let us go back and select the manager of our smart contract. Now let us call this get balance function, and now you can see that we have a balance of 3 ether, right? And now let us call the pick winner function. So currently there is no winner, right? And now manager is calling this pick winner function, and now let's check the winner. So you can see that 0 cross 4b2 is the winner of this lottery, and we can see that in his account also whether he has all the ethers or not. So you can clearly see that 04b2 is now having 101 ether. Currently he was having only 98.99. After 1 ether he has given as a depositing fees for participating in this lottery, and now he has received 2 plus ethers. That's why it is 101.99 ether, and now he is the winner of our smart contract. And since, if you will see, we have made our players array 0. So if we will go back and check whether we have any addresses left in our players array or not, so you will see that we do not have any addresses. So you can clearly see all players is 0. If you will again call this at second index, okay, I think it is not showing us 0. Okay, I think it is stuck, right? So you can see that it is not 0, but it is stuck. No issues, but still, one thing is for sure that our lottery smart contract is working perfectly fine. And let us copy this lottery smart contract and paste this to our Visual Studio Code. So in the previous video, we have seen how to create our smart contract, right? Now in this video, what we are going to do is we are going to deploy our smart contract. And to deploy our smart contract, we need a tool that is called Truffle. Now, I already have created the structure for our decentralized application. And what is this structure all about? You will understand. Just have some patience, you will understand. For now, what I'm going to do is I'm going to clone this repository to my VS Code folder. So I have created a folder, lottery tutorial, and inside this, I'm going to clone this repository. So let me tell you one thing, that I'm going to use this lottery branch. Okay, in this lottery branch, so you do not need to worry about it. Just to tell you that I'm using this lottery branch of this repository. And now what I'm going to do is let me copy this code. Okay, and I will explain you this structure, so just have some patience. And now in this, what I'm going to do is I'm going to do git clone -b. And since we want to use the lottery branch, right? There are two branches and I'm using lottery branch and then the code that we copied from the git. And I will just clone this. So now you can see that I have this Web3 lab folder, and inside these we have certain folders. Now, first of all, let me clear this out. Now what we are going to do is, first of all, we are going to paste our lottery smart contract. So in the contracts folder, if you will see, you will have this lottery.sol. Now in this lottery.sol, we will paste our lottery smart contract that we have created in the previous video. So let me paste the contract here. Okay, so the same contract that we have created in our previous video, I have pasted here. And now let us deploy this. And now in order to deploy this, we are going to use a testnet, that is Gorilla testnet. And let me show you the migrations file. So in our migrations file, you can clearly see that we have lottery.sol. Okay, the name of our smart contract is also lottery.sol, and we are just going to migrate it. Now in order to migrate it to our test network, I have to go to this Truffle configuration file. Now inside this, since we are going to migrate it over a testnet, we need certain things. So the first thing that we are going to need is this HD wallet provider. I will uncomment this. And then we are going to need one more thing, that is the mnemonics. So I will paste this. I will show you how to do that. Okay, so this is the second thing that we are going to need. Third thing that we are going to do is we are going to comment this out, because we are not going to deploy it on Ganache, a local blockchain. We are going to deploy it on a test network. So let me go above. There you can see one option for where it is, Ropsten, right? But we are not going to deploy it over the Ropsten test network. Reason being, Ropsten is going to get deprecated after some time, so we are not going to use this. Instead of this, we are going to use Gorilla. Okay, if I am mispronouncing this name, so sorry for that, but this is the thing. And then the network ID of Gorilla is 5. Okay, and then we will require a link here, and for that we are going to use Alchemy. Okay, so we will use Alchemy because we cannot directly deploy our smart contract over a test network without being a node. So if we want to deploy our smart contract over a node, or not over a node, over a blockchain, we have to install, you know, the software like Git or something like that in order to deploy it over the blockchain. But this cannot be possible for all of us, right? Because that is a very hectic process. You need to, you need to become a node, you need to install all the blockchains and all those things. So what we are going to do is we are going to use Alchemy. Alchemy will actually help us to directly deploy our smart contract over the blockchain. So Alchemy will become a medium, a bridge between our system and the blockchain. So Alchemy will do all the talking with the blockchain. We just need to provide the link here, the API key here. Okay, I will show you how to do that. So these are the things that we have to do. So first of all, let us install this HD wallet provider. So let me go above. Okay, so the first step should be this. I will copy this. I will do cd web3 lab. In this, then I will install npm install this Truffle HD wallet provider. So let us wait for it to be installed, and once it is installed, then we are going to or let's go to the Alchemy website. I will share the link in the description of this Alchemy so that you can directly click on it and directly go to the Alchemy website. You have to simply just do a simple sign up process if you haven't created your account on Alchemy. Otherwise, it's a very simple process. Now what you have to do is, here I will create an app. So you can clearly see it is asking the name. So let me name this as lottery, right? Lottery D app. And this is optional, and in this we are going to use Gorilla. So you can clearly see here that Rinkyb Robson is deprecated, and now Rinkyb is also going to be deprecated. I'm going to use that swag Gorilla. Okay, so I'm going to create this app. Okay, so let me go to the Gorilla and I will click on the view key option. So now we will copy this link, right? This HTTPS link that you are seeing on your screen, right? I'm just going to copy this. I'm going back to my VS Code, and now you can see that HD wallet provider is also installed, and I'm going to paste this link. Okay, let me show you where. Okay, here. Okay, so we will paste this here. Now once this is done, then we need the mnemonic, right? HD wallet provider is done, so this will help us. Now this is done. Now we have to do this, that we need the mnemonics. So where we will get the mnemonics, we need to go to our Metamask wallet. And yes, one more thing, if you do not have any of Ether in your Gorilla test network, what you need to do is you need to go to Gorilla faucet. Now again, if you will see, you need to sign in to Alchemy. The reason for this is that they are doing this for some security reason. So just sign in if you haven't signed in yet. So just sign in to Alchemy and then just paste your account address in which you want the Ether from. Okay, so let's say I already have some Ether, but let me try once again. Let me see whether they are going to give me some Ether or not. Sometimes they reject these type of proposal when you already have some amount of Ether in your account. So let me try. I will do this. I will paste my account. I will click on send me ETH. So you can see that the transaction is in process, and I'm already log into this Alchemy. Okay, and that's why this process is fast, and we are going to get this 0.25 Ether. Okay, so it is taking some time. Okay, so it is taking some time, but I already have some Ether, so you have to wait for a while, and once this transaction will be processed, you will see that you will also have some amount of Ether in your Gorilla wallet. Okay, so just select Gorilla test network only, guys. Okay, we have so many test network, but just select this Gorilla test network only, because other test network are going to be deprecated. Okay, and once you have done this, now it's time for the mnemonics, right? So just go to the settings. In this, just go to security and privacy. Yes, reveal secret privacy secret recovery phrase, and then type the password of your Metamask wallet. Okay, I will do next, and now this is my secret recovery phrase. So this is for demo processes, that's why demo purpose, that's why I'm showing you this. Otherwise you should not reveal this secret recovery phrase to anyone. This is just for demo purpose, that's why I'm showing you this. And all these things that you are seeing in my wallet are actually fake Ethers, so do not try to hack me or something. All these are just fake Ethers. Okay, so I'm going back to my VS Code. Inside this I will paste my mnemonics. Okay, so now each and everything is done. We have our HD wallet provider, the mnemonics, as well as we have our Metamask wallet connected by this. This mnemonics is actually working as our signature. Okay, so this is like when you are going to sign your transaction. So these mnemonics will be required for that. And then we have this Alchemy link also, so that we can talk to the blockchain, so that we can deploy our smart contract to the blockchain, on the blockchain actually. Okay, so now each and everything is done. Let us now deploy our smart contract. So now let me clear this, then truffle migrate dash dash network and the network name, that is go. Okay, I must see the spelling here if I have mistaken in the spelling, so it will not affect that much. So now I'm deploying it to the GoReality test network. Now let's wait. So first the compilation of the smart contract is taking place. Let's hope each and everything is fine. If there will be some issue, then we need to resolve that issue also, right? I think the compilation, the deployment process has just begun because it is getting deployed to the test network. So it might take some time. So we need to wait for a while because our test network works just like our main network, right? So yes, let's wait for some time. I hope it will work fine. So you can clearly see that we are now currently waiting for two confirmations. And the reason for this is because of this line, because we are waiting for two confirmations and now our smart contract is deployed. That's a wonderful news. Let's see our smart contract address. So this is our smart contract address. Let me copy this. Let me go to our MetaMask so that we can see our deployed smart contract, right? And just please do not forget to copy this as contract address. This is very necessary. You should not uh, because we are going to need it, right? Because we are going to need this smart contract address. So just do not uh, lost it. Yes, that's the correct word. Do not lost it. Okay, I think this is our smart contract which is deployed, but let me see. Let me paste the address. Yes, so now we have our smart contract. Let me see the transaction. So you can clearly see that this is our smart contract which is deployed over the GoReality test network, and this is from this address. Let us confirm this also, whether the same address has deployed this smart contract or not. So yes, you can clearly see that 0BE4 is the person who has actually deployed this smart contract. That's a good news. Okay, so our smart contract is totally deployed to our test network, and that's a very wonderful news. Let us go back to our Visual Studio Code. Okay, so now we need to create our decentralized application, right? So how we can create our decentralized application? So we need to go to our client folder. Let's look at our client folder because our smart contract is ready. It is deployed. Let me copy this address also so that we do not forget this, right? We do not lose this address because we are going to use this in future, right? So I'm going to paste this here. And now let me go to the client folder and let me tell you that what are the things we already have in our client folder so that we can start with our decentralized application. So let me go to the client folder. Now inside this client folder, you can see that we have a lot of things. You can definitely delete some of these things like yarn.log and packet.log JSON. You do not require both of these things, right? So you can delete this. You can delete this readme.md also. We do not require this. And in this public folder, we do not require this. I can also let me have this. Okay, let me delete this. Delete this logo and delete this logo so that it does look clean a little bit, right? Okay, in our, so this is our public folder, this is our source folder. Inside our source folder we have all our important files. This is the place where we are going to create our front end of our decentralized application. So let me show you this front end. Let me explain you some of the things that I already have done here so that you do not need to do again and again. So the things that you are seeing here, right, this is the basic structure of your uh, I will say decentralized application. So whenever you need to create a decentralized application, right, you can copy paste the same code in your VS Code or wherever you are creating. Okay, the only things that you need to change here is this JSON format. Now, what is this? This is actually the ABI of our lottery smart contract. So if you will go to your contracts folder, which is here, so you can see that we have this lottery.json, right? This lottery.json is actually the ABI of our smart contract. So in order to interact with our smart contract, in order to talk with our smart contract, we need this lottery.json. Okay, so this lottery.json act as a medium so that we can talk to our smart contract. So let's say if you are creating some other application, let's say you are creating some crowdfunding smart contract, then in that case you will have your crowdfunding application name here. Okay, just remember this. And then We are using React application here. And then you can see that we have a little bit of code here. Let me explain you this code also so that you are not confused that what we are trying to do here. This is, as I said, this is the basic structure. Whenever you are going to create a decentralized application, you need to have this structure, nothing new. You have to have this one. Just remember this. So the first thing what we are trying to do here is we are trying to import our web3 object. So if you will go to this get web3.js, so here you will see that we have a code for our for connecting to our MetaMask wallet to check whether web3 object is present or not and all those things. I'm not going to explain you this because this is not something this is some simply, I will say, this is simply the MetaMask code that is written here in order to connect to our MetaMask wallet. Nothing more, nothing less. It is easy. Just you can have a look at it. The only thing that we are trying to do here is I'm in the wrong. Where is that app.js? Okay. So first of all, we are doing that, okay, because we need Web3 so that we can connect with our smart contract. Then we are actually having the network ID. Because why we need this network ID? So that we can have our contract address. So you can clearly see that I'm using this network ID, then I'm using this here also, and then I'm using this deployed network dot address in order to get the contract address. So once we will start this application, you will see this also that you will have your deployed network dot address, smart contract address here also. And why you will have that? Because now you have your lottery here, right? This lottery.json. This lottery.json will actually help you with your with the smart contract address. So the smart contract address that you have deployed over the blockchain, you will have that here. Okay. Then what we are trying to do here is we are trying to create an instance. We are trying to create an instance for our web3 object as well as for our contract. So why do we need this? We need this in order to talk to our smart contract, and you will understand it once we will create once we will start with our decentralized application. You will see that I'm going to use this web3. Okay, so I'm using this set state so I have to set this object, and I'm going to use this contract instance in order to talk to our smart contract, and you will understand it once I will start with our application. And why I'm using this try catch here? Because if there is some issue within this code, I can catch that error, and that's why I'm using this try catch. There is nothing more to it, and I'm simply calling this init function so that I can run this code. And I have our web3 we have our web3 .js library, we have our web3 object so that we can have all the functionality to talk to our smart contract. We have our contract instance so we can talk to our smart, means you will understand. Just have some patience. Okay, so this is a very simple type of thing. So what first of all we need to do is we need to install it. Okay, install the package.json, the dependencies that we require. So I'm going to the client here, and then I'm going to npm install all the dependencies. Npm install. So let's wait for a while so that all the dependencies get installed. So this will actually install our React.js application so that we can create our application using React.js library. Okay, so our React.js application is now installed, and we can check this also. Let me do npm start. Let's check whether application is running fine or not. Okay, so our React application is running. Definitely we have this error, and the reason for that error is because we haven't connected our MetaMask wallet. So this is my different browser, that's why I'm not connected to Gorilla test network here, and that's why it is showing us this error. Okay, so now you can clearly see that React application is now working, and I'm going to click next because it wants to connect to my Gorilla test network. And remember guys, if you do not have a MetaMask wallet, or if you are not connected to Gorilla test network, then it is going to throw you an error. Okay, please try to connect to the MetaMask wallet and try to have Gorilla test network only. Okay, otherwise it will give you an error. I'm going to click on connect, and now our MetaMask wallet is connected to our D app. Okay, this is not a D app, but still. And let me show you one thing more. So now if you will see, we have a lot of errors, right? But do not worry about these errors. Some of these errors are of no use, and we will resolve all these. But one important thing that I want to show you here is that we have this contract address here, right? And how we have this contract address? Because we are actually printing it, right? As I said, because we are going to use this deployed network dot address, because we are using this deployed dot address in order to print this contract address. And if you will verify this, you will see that this is the same contract address that we have deployed, just deployed, right? Okay, so this is the wrong browser. Okay, now this is the correct browser, and here you can see that we have our contract address. So now we have completed one more step in order to create our decentralized application. Let me meet you in the next video. We are going to start our React.js application. Okay, so this is how our decentralized application will look like. We will have two people, means two entities, one manager, another one will be the player. And when manager will be like, if you are a manager and if you will click on manager, you will have all these options like click for winner, as we have seen in our smart contract, the balance of our smart contract, and the connected account. But only manager will have access of this front end, and you will understand why this is so. We will have such type of functionality. And let's say if I have to go back, I will go back to my player uh, page, and in this you will have the connected addresses, the registered players, that players who have already registered to our decentralized application, and this is the amount the user has to pay, the player has to pay in order to participate in this lottery. So definitely the CSS of layout of this decentralized application is not much, heavy type. And the reason for this was very simple, so that we can totally concentrate on how to create a decentralized application and not how to, create a beautiful CSS. You can make changes to this CSS as per your need. You can definitely have a lot of different styles, a lot of different, modals or something like that, as you wish. But in this video, we are mainly going to focus on how to create a decentralized application, like how to connect your front end to your blockchain so that you can do it by yourself. Okay, so this is the whole idea of this decentralized application. Now let's go back to our Visual Studio Code and let's start creating our decentralized application. Okay, so in our project, what we are going to do is we are going to use Bootstrap. So in order to use Bootstrap, what I'm going to do is I'm simply going to copy these script sources. That is, this is for, I think, yeah, this is for JavaScript, because you can clearly see that it's for min.js. And the first script, this script that you are seeing, this link that you are seeing actually is of CSS. So I'm going to copy these two things in my index.html code so that we can use Bootstrap in our code. So what I will do is I will simply take this. Okay, I will simply take this. Let me see whether I have taken the right code or not. Yes, I will go to my VS Code. In this, I will go to index.html, where it is in public index.html, and below our, okay, this is link. Okay, right. So let me remove these things, right? Do not require this. And let me remove this. Okay, now after our title, we will have this so that we can use Bootstrap CSS. And let's say if you want to use Bootstrap JavaScript also, then what I will do is I will simply take Bootstrap JavaScript. Okay, no, this is not the right place. This is the right place. I will simply take this code, copy this, go back to my VS Code and paste this here. Okay, so that we can use Bootstrap. Now everything is done. Let me close this and let me go back. Okay, so now we can create our smart contract, not smart contract, our front end. But before that, let me do one thing. Let me do one change to our Truffle configuration.js. So the code in our Truffle configuration.js is for our test network, right? But directly using our test network to, because we are going to create our decentralized application, we are going to test it. So using directly test network for this thing will be a time taking process, because if we are going to make some changes, let's say if I'm calling some function on our smart contract, then it will take some time, because we are directly connected to a test network. So for our testing purposes, so that we can test our decentralized application before deploying it to the test network, what we will do is, for now we will comment these out, these things. Okay, and we will use our Ganache so that we can quickly check our decentralized application, and once our decentralized application is ready, then we will use our test network. So this will save a lot of time, right? Because Ganache is our local blockchain, so it will not take so much time as test network, right? Because if you are going to use the test network, and let's say if you call some function from your test network, like because your smart contract is on a test network, right? So it will take around 15 or 10 seconds to have the results, right? So to avoid this, just to test our smart contract, I will just comment some all these things, and we are going to use our Ganache. Once we are done with our decentralized application, once our decentralized application is again ready, then again we will uncomment these things, and then we will comment out the Ganache part. So to use Ganache, simply let me search for 8545. Yes, here it is. So I will simply comment this out. No, I think this is not the thing, right? We are searching for 8545. We read. Okay, I think 7545. Yes, so this is our development server for our Ganache. Okay, let me open my Ganache. Okay, so this is our Ganache. For this, we will use new workspace. Okay, so that we can have our Truffle configuration file placed here, so that we do not need to again and again restart our Ganache. So once we will deploy our smart contract over Ganache, it will be there till the workspace is created. So now what we will do is we will simply add our project to our Truffle projects. So here you can see that this is the lottery tutorial folder. I will go on this. I will go to Web3 Lab. I will select my Truffle configuration file. Okay. And I will have this here. So once we will have this here, so this will be our workspace, and let me name this workspace as lottery tutorial only, so that I do not forget tutorial, and I will do save workspace. So now this will be our private blockchain. This will be our private blockchain. So this will be very helpful in order to quickly test our decentralized application. Okay, so now this is done. Now once this is done, just come to your Metamask wallet. Okay, and in your Metamask wallet, use Ganache UI. If you do not see an option for this, let me show you what you have to do. Now, in order to have your Ganache UI ready, what you have to do is simply go to settings. In this, go to networks. Inside this, go to, if you do not have an option of Ganache, just click on add network. Once you will click on add network, just have all these things that I have mentioned here. Have your network name as Ganache UI or whatever suits you. Then the RPC URL, this RPC URL is present here if you will see. So I'm using this same RPC URL. Then the chain ID 1337, and then the symbol, whatever symbol name suits you. You can have ETH also, but I'm using CPAY. Okay, and now if you will do all these things, you will have your Ganache network, test network, not test network, yeah, private network, I will say, in your Metamask wallet. Now once you have this, just import some accounts so that we can quickly test our decentralized application. So what I will do is I will show keys. I will click on show keys. I will copy this private key, and I will import this here so that we have some accounts to play with, right? So I am going and importing, and here is my private key, import. So now you can see that I have 100 CPAY, the same that I have here also, right? Then we will have this also. Let me do this for at least 3 accounts so that we have 3 participants and 1 manager, right? So done. Let me again go back. I will again go for import account, paste here, import. Okay, and now I'm going to do it quickly so that you can also do it and your time is not wasted. Okay, so now this is done, and you can see that I have 4 accounts in my Metamask wallet, and all these, okay, I have a lot of accounts. Okay, so you can clearly see that I have a lot of accounts here. I will select the first one, that is 40. This will be our manager. Okay, now everything is ready, and now let us create our decentralized application. Okay, so before moving forward, let us deploy our smart contract on our Ganache blockchain, right? Before that, we have deployed our smart contract over a test network, and we are going to use it. No issues with that. But for now, let us deploy our smart contract over Ganache so that we can directly access it from there only. Now to deploy it, again, I am going to my Web3 Lab folder. And in this, if you will see, we have our truffle, right? Now what I will do is I will simply do truffle migrate dash dash reset. Now this will migrate our smart contract over our Ganache blockchain. Let's wait for some time so that it get deployed. If we have made our changes in a correct way in our, in our truffle configuration, truffle dash config.js, then everything will work fine and it will get deployed. So now you can clearly see that our smart contract is deployed on the blockchain, and we can see the contract address, right? Let us see the contract address first of all. So what is the contract address? So this is our contract address, right? Let me copy this down also, just for safety. We might use it in the future. I'm not sure about it, but yeah. So let me have this here. So this is the smart contract for our Ganache, right? So this is it. Okay, wonderful. So now let us go to our client folder now, and now we can make changes to our manager.css, right? Or not CSS, actually manager.js. And before that, let me go to app.js. So source app.js. Okay. And let me create one more folder here. Let me name this folder as components. Okay. So these will be our components. And in this, I will create two files. One is manager.js. Okay. And then we will have manager.css, okay, to have our CSS file. Okay, so let us create our manager.js first. We have seen, right, how our demo application looks like. So first of all, we are going to need React, okay, React, and in React, then we will need use state as well as use effect, okay, and you will see why we need this. So from React, then we will be needing our CSS file, right? So I will provide you the code of manager.css, so you don't have to worry about it. So we will use that. So let me paste the code that I already have, and I will share this code with you so that you can also paste to your manager.css file. And now we will create our component, right? So the component name will be manager, and then we will have, okay, I made a mistake here, our manager. And beside this, we will have export default manager, okay, so that we can use our component. Now in our app.js, we will require this component, right? We need to, so that we can, we need to render this component also, right? So let me go to app.js. Let me import manager.js here. So it is in current directory, okay, current directory components, and we have our manager, right? And then we will have our manager code here. So let me have this manager component. Okay, now since we are going to create our manager component and we are going to require this state, okay, we are going to require this state because this state object consists of the web3, which we will be using in order to call the functions and all sort of things, and another is contract instance, so that we can talk to our smart contract. So we require this object, so I will pass this object here in this component, okay. So state, okay, I hope you know all these things. These are the part of our React.js application only. And then in our manager.js, I will take this as a prop. So state. Okay, so now we have our prop ready. And now what we can do is we can create all the states that we are going to need. Since as we have seen in our demo application, we need certain amount of states, right? First is we need the account. Second, we need balance. Third, the lottery winner. And I think, yeah, I think three things we need, right? So account, balance, as well as the winner. So let us create all those states so that we can directly use them when we will create our logic. So first will be account. Okay, so set account, and then use state. Okay, And then we will require one more state, that is our balance. So contract balance, so I'm denoting it by C balance. So I will set C balance, and then we will have here 0, right? So initially the balance of our contract will be 0, so that's why. Then we will have our lottery winner, so I'm denoting it with LW, winner, okay. And then in this we will have our set L, winner, right? And then we will initially have a statement that no winner yet, okay. So we will initialize this by no winner yet. So now we have all our states ready, right? Now we need to just create our function so that we can proceed with our manager.js. So first of all, we will require a use effect, and in this use effect we will have our account. So with the help of this use effect, what we are going to do is we are going to get the account that is connected to our MetaMask wallet. Means once an account will connect to the MetaMask wallet, so whatever account is connected to the MetaMask wallet, we want to display that to our manager.js front end, okay, so that we can know like who is actually the manager of our contract. So we will create one function by the name of get account, okay, and this function will be async, and the reason for it is it will be async because we are going to deal with promises, okay, and to resolve those promises, not resolve actually, to so that we can use promises, I'm using async and await. So first of all, I will have my web3, and how I will have my web3 through my state, okay. So I'm using destructuring here, and from state I will have my web3. Now using this web3, now you will understand the use of why we need this web3. So let's say I want accounts, the number of accounts that we have. So we will create web3 await web3 dot eth dot get accounts. So this will provide us the list of all the accounts, okay, and I will show you that also. Console dot log, so that we can see all the accounts that are there in our blockchain. So accounts, okay, and then we will set our account, okay. So accounts 0, we require account 0. Why? Because you will understand. Let me show you that so that you can better understand why I'm selecting account 0 here. You will understand that because when we are going to switch between accounts in MetaMask wallet, so that will be account 0, and you will understand when once we will use it. So let me remove this terminal right currently for now, okay. So now let me do state, means let me call this get account function. And so what we do not want is that get account function get called whenever this use effect will start working, right? We do not want that. What we want is that once we have our state web3 state.web3, then only we want that get account function should be called. If we do not have state.web3, we will not call this get account function, okay. So that's why. Other things that we need to take care of is that we should have the dependencies list. So state.web3 and state web3. So this will be the list of our dependencies. I hope you know how use effect works, okay. So this will actually help us in getting the accounts, and we can see that also. Let me show you so that you can better understand it. So let me return, and inside this return I will have this. Or let me do one thing, that let me show you in console only so that you can directly see there, and once we will over with this, then I will show you on front end also, okay. For now let me just save it, and let's hope we do not have any errors, and let me npm start cd client, and let me clear this, and then npm start. Let's hope that everything will work fine, and we will see our accounts. Okay, my remix id is open. Let me close it. Okay, I think we made some mistake. Can't resolve manager.css. Okay, I think we made some mistake. Let me see that mistake. So let us see what mistake. Okay, I made mistake in the spelling. Let me save this correctly. Okay, I think everything is working fine right? Okay, so it is, let me connect my MetaMask wallet to Ginash. Now let me open my console. So you can see, okay, this is our contract address that we have deployed on the blockchain. And this is our address in our array, right? So this is 091D. And if you will see in my MetaMask wallet also, you will see the same account address. And if you are seeing some different address here, guys, just refresh it. Sometimes this shows some cache result or something like that. I have seen this thing also. So just refresh it and you will see the exact address that you are connected from your MetaMask wallet. So in this, you can clearly see that when MetaMask wallet is connected to this account, and this is the account which we are connected also here also. It means this is the account that we are actually being shown in the console also. Now you must be wondering why we are not being shown the array of accounts, and the reason for this is because we are actually directly communicating with MetaMask wallet, and that's why we are being shown this. But if, let's say, if you will directly connect to Ganache, okay, because at this point of time we are this MetaMask wallet is actually acting as a mediator, okay, and if we will directly connect to Ganache, and then when we will do web3.f.get accounts, you will see all the account addresses that are present in Ganache. But currently, since we are talking with MetaMask wallet and MetaMask wallet is acting as a mediator, so in this case, it is showing us the array addresses as this account only, means the account that you are currently connected to. So let me change the account. You will see that you will see a different address. Let me select this account. Okay, let me connect this. Now you can see that I am connected to 0A38. Let me refresh it. So you can clearly see that I'm connected to 0 cross A3A. Okay, so this is what we are doing till now. Now, definitely this functionality does not look good, right? When we have to refresh our browser again and again in order to get the account address, means the account address that we are connected to our wallet to, right? So what we will do is we will add certain functions which will help us in avoiding such type of inconsistency, right? We do not need to then again and again refresh our browser in order to get the current account address, and you will see that also. Okay, so till now we are going good. Let's go back to our Visual Studio Code. Now let us create one more function, and this function will actually fetch the balance of our contract. So contract balance, let me add a const also, const. Okay, so this contract balance function will fetch the balance of our contract, and this is also we have seen in our manager.js front end also, right? So let me have const, and now I will fetch my contract instance. I will use state. So this is the state that we are using. So we are using destructuring here, and then we will have balance. And since we want to fetch balance of our contract, so what we will do is we will call this, let me show you this get balance function. Okay, so we need to call this get balance function, which is a part of our lottery smart contract. So what I will do is I will do await contract. So the contract that we have fetched from state methods. Okay, then get balance. Now this is syntax of our web3.js library. Okay, so just get used to it. So I'm calling this get balance function, and I'm using call, and which account, from which account I want to call this function. I want to call this function from the connected account. So this, we are setting this account here, right? Set account. So this set account will give us this account address. So the account that we are connected to, we are actually calling from that account only this function. So let's say if I'm connected to 0A cross B account, so that 0K cross B account, when this balance function will be called by 0A cross B, then that account address will be present here. Okay, so we will do this in a practical way also, then you will more understand if you are still not getting what I am trying to say. So just have some patience, you will understand once we will test our DR. Then what we will do is we will set the balance of our contract, right? So I have created this use state, right? This use state balance. So I'm using the same here to set the balance of our contract. Okay, now this is done. So by this we can set the balance of our contract. But let me show you one interesting thing here, that this get balance function can only be called by the manager of our contract. Means if someone else is trying to call this function, we do not want him or her to give the access, right? That's why we have this require statement. So if this require statement is true, means if this expression is true, then there is no problem. We can directly go to this line. But if this require statement, this expression is false, in that case, we will throw, means not we will, actually this require statement will throw an error, that is you are not manager, you are not the manager. So we need to take care of this require statement also in our manager.js. And for that, how we can take care of this, we will use try and catch flow. So I will use try. I will take these two things, I will push them up, and then I will have my catch block, so that if there is some error, in that case, what I will do, I will set our C balance from you are not the manager. So if our require statement will throw us an error, means let's say if we are connected to account another other than manager. So let's say if a manager account address is 0a cross b, 0 cross ab, and let's say we are calling this this function, this get balance function from 0 cross cd, in that case it will throw an error, that is you are not the manager, and we will set that to our front end. Okay, I'm using a very simple functionality so that we do not have a lot of complexity. So I'm just trying to make this DApp as simple as that, so that you can easily understand the core concept of the blockchain that we are actually using here. Okay, now, so this is set. So the first thing, the account is set, and now we have our balance also. I will show you the balance, so just don't worry for now. And then we will have the another function, and that function will be the winner function. So winner, and again it will be async, and in this again we will require the contract instance. Okay, and again we will use state, because that state consists of our contract instance. Let us go back to our lottery.sol. Now how we can pick the winner of our lottery. Now in order to pick the winner of our lottery, first we need to call this pick winner function, right? Because when this pick winner function will execute, then only we will have the winner address, right? Because if you will see, we have our winner as our state variable, right? So once this pick winner function will be called, we will have the address of our winner in our winner variable, right? In this winner variable. So we need to call this pick winner function so that we have the address of our winner in our winner variable. And then we need to call this winner function, because as we know from Solidity that if you are creating a public variable in Solidity, then automatically a getter function for that variable is created. So I can call this winner function in order to fetch the address of our winner. Okay, and you will understand. So first what I'm going to do is I'm going to call contract methods dot pick winner function. So I'm calling this pick winner function. Then this time I'm not going to use call. Like if you will see in the previous function, I have used this call, right? This call thing, so that I can call this function. But in this case, I'm going to use send. Now, why I'm going to use send? Remember, this is a very important point. You must remember this point, that whenever you are changing the state of your blockchain, in that case, you are going to use send. Means this function, this pick winner function is going to change the state of our blockchain. Why? Because now you can clearly see that we are actually changing the state variable. So we are actually making some changes to the blockchain. We are actually performing some write operation to the blockchain. So for that reason, we need to have this send here, not call here. Call is only for read only methods and send is for write only methods. So I'm going to use this here from again the connected account. As we have seen also, we are actually having set account 0, right? So the connected account will be here, set account 0. So account, okay. And now once we will do this, we will have the winner's address, right? In this winner variable. In this winner variable, we will have the winner's address. Now, another thing that we need to do here is we need to call the winner variable. So you will understand. So contract dot methods, again, I'm using the same thing. Now I'm going to call winner function. What is winner function? This is winner function. Since it is a public variable, so a getter function for this winner variable is already created by Solidity, and I'm just calling this winner function here. So again, since this is not changing the state of our blockchain, I'm going to use call here, not send, but call function here. And once we have the lottery winner, we will set the winner of our lottery. So this is done. Okay. But there is some issues here. Let me show you those issues. So the first thing is that this pick winner function can only be called when the manager of our contract is calling this function, right? So that's why we have this require statement. Another require statement says that since this pick winner function can only be called when the length of the players, means when the number of players is greater than equal to 3. Now again, we need to use our same try and catch block here also, right? Because definitely this time we are going to deal with two require statement, but this time we again need to use our try catch block. I hope you understand why we are using try catch block, because this require statement can throw us an error. In the first case, it can throw us an error that you are not the manager. In the second case, it can throw us an error that players are less than 3. So to avoid that, we can use a try catch block. So what I will do is I will have my try block. Okay, now I will take all these things in my try block. Then I will have my catch block E. Now in this, I need to have two conditions. I need to check the two things, right? First, like from which require statement we are getting the error, from the first require statement or from the second require statement. So for that, I'm going to use if E dot message dot includes. Okay, so this is syntax from JavaScript. Where means if this error message includes that you are not the manager, because this is the error thrown by our require statement. In that case, what we will do is we will set lwinner with you are not the manager. Okay. Otherwise, else if e dot message dot includes that there are less than 3. Now one very important thing, let me tell you here, is that always and always have the same statement, because this is a thrown error, right? So have the same exact statement inside this e dot message includes. Otherwise, you will get a wrong result. So okay, remember that there should be no mistake in this message e dot message dot includes, and this message, the error thrown by the required statement, should be the same. Okay, that will be good. Otherwise, it might give you some wrong result. So if you will check, in my case, I'm using the same. Okay, I'm not using the same. Let me use the same, right? I'm using the wrong statement. Let me have this here, right? So let me have this here. This is very important because your error message includes these statements only, right? So again, we will set lwinner in this case, the lottery winner in this case, that there are less than 3 players. Okay, nice. And then at the end, we will use our else if both of these things are like the issue is not because of these required statements. In that case, we will directly print that set lwinner. Let's say someone is calling this function, he's the manager, and means if these two conditions are false, if you are not the manager, if these two conditions means are false, in that case we are going for this thing, that no winner yet. Means if we have some issue, in that case we will go for this statement, that no winner yet. Okay, that's good, I think. Now this completes the logic of our manager smart contract. Okay, and let us check this also so that we do not think that what is actually going on. Let me console.log the balance. Let me see the balance, initial balance, and let me also check the lottery winner, right? Just for the sake. Console.log lottery winner. Let me save this. And since clearly you can see that these two functions need to be called, right? Because one is contract balance and another one is winner, and both of these functions need to be called so that we can have a result. So we need to have certain things here. And what we can do here is we can simply print the connected account. Okay, and this will be our connected account, right? Let me have a simple break statement, and we will improve the CSS, guys, so don't worry that if you are not getting like what I'm trying to do here, just don't worry, we will improve the CSS of our code also so that we have a good looking code at the end of our decentralized application. I just do not want to waste time, and that's why I'm using this shortcut method with you. Okay, then we can have another statement, that is another not statement but another button, I will say button, and this button will be for click for winner. Okay, and if we will have the winner, we can show that winner also, right, by having winner L winner. So you can clearly see that now it is very easy. I'm just simply using the variables, that the state variables, right? L winner, this L winner, this L winner, and this C balance account, so that we can show them on our front end. And then at the end, we will have the balance. So let me again have a break statement here so that we will be on the another line. So balance, what we can do is contract balance, and in this we will have our C balance, right? Now again we will have on button, and this button will actually help us in calling this. Okay, so in this button we should have a functionality also, that on click, when someone will click on this, in that case we will call our winner function, and when someone will click on this, on click, in that case we will call our balance, contract balance, right? What is the name of a function? Contract balance, right? Contract balance. Okay, there is a mistake, let me put it. Okay, so this is our basic syntax is ready, I think. Let us see how it looks. Okay, it does not look that bad, and okay, we have this button here. Definitely we will improve that, so don't worry. Okay, we will, let me call this click winner. So you can clearly see that when I'm calling this click winner function, it is connecting to our Metamask wallet, and you can clearly see that it is saying that you might this function might not work, and the reason is very true. How this function is going to work, because conditions are not being met, so that's why it is saying that. So this is good. And why I'm not seeing my balance button, let me see that also. Okay, actually we haven't written anything here, so we can write that balance. Okay, let me write that only. Let me go back. Okay, now we have this. So balance, so you are not the manager. Okay, that's good, right? Because our if you will go to our MetaMask wallet, if I will go to my MetaMask wallet, so this account is not the manager. Who is the manager of our contract? So this address. So because when we have deployed our smart contract using Truffle migrate dash reset, in that case, this address was the by default address selected by that was selected, and this address is the manager of our contract. Okay, so how this, like, why this address is selected as the manager of our contract? This is because when you deploy using Truffle, right, doing Truffle migrate reset, in that case automatically the account 0 means zero index account of our Ganache gets selected. So zero index account, that is this account, was selected when we were doing Truffle migrate reset. And since this account was selected, that's why this account is the manager of our contract. So if you are going to select any other account to call this balance function, it will not work. So let me select the manager again. Let me go and select the manager here. So this is our manager, right? So this is our manager. And now let me call this. So you can clearly see that, okay, there is some issue here, but now let me refresh it. We are going to rectify all these things, but let me call this again, balance. So now you can clearly see that it is showing us 0, right? This is what we console.log also, and it is showing control contract balance as 0 only. So there is no issue with that also. Let me call this again, click for winner. So no winner yet. That's also good. It is working, and this is the connected account, right? And this is our manager of our contract, and this manager is connected to our DApp. So this is something good. We have actually completed the manager functionalities, but definitely we need to improve the UI. That this is not looking good at all. But functionality is working. That's a good sign. So let's improve the UI. Okay. So here I have written all the CSS classes that were necessary in order to improve our UI. So do not think like I can write these things down, but that was a time consuming process and I do not want to waste your time. So you can simply copy paste the code from my GitHub repository, which I will share in the link below. You can simply go and copy paste this. So I'm using certain classes which are actually provided by our Bootstrap and some of the classes that I have made. So which for that code is present in our manager.css. Now let us go back to our DApp and let us look how it looks. Now it looks good, right? Definitely we are going to arrange all these things, but still it looks pretty much fine if we will compare it from before, right? So I'm clicking on this, okay, everything is working fine, and this account is connected account. Okay, so now this is good. Now let's make some changes to our, okay, so I have made changes to our CSS file and now it looks good, I think. So we have our connected account, we have our winner, and we have our balance. So this is good. So this is our manager.js page, and now let's go to our player.js page. Okay guys, so now we will create one more component, and that will be players.js. Now again we will import our React as well as our use effect, use state, and then we will have, okay, it's not equal to but from, and then React. Okay, and then we will have our players component. So players, and this, in this we will require 2 props. So let me go to app.js. We will require 2 props here. Okay, for now I'm commenting this out because otherwise it will create some issue with us. So let me go down. Okay, for now let me comment this out. Okay, and we will activate it once we are done with our players component. So players, so we will require this here. Now in players we will require 2 things. First will be the state, and another thing will be the address that we have also set, right? The contract address. So let me have the state, okay, and as well as the contract address. We will require this contract address, so that's why. Let me go back to state, and in this in our props we will have a state, we will have address, and then we will have this. Okay, let me export this out also. Export players, export default players. Okay, now so again let me create some of the states. So we will require an account state, registered player state, as well as no state. Yeah, only 2 states. Okay, so we will require 2 states here. So let me have all the state, const account, set account. So we will require 2 states here. First will be account state, so that we can have the connected account, and another state will be registered players. So account, then set account, and you can see that creating a DApp is a very easy process, right? It's not that difficult as it seems. In most of the YouTube videos you might have seen that they do so many things, but you do not require to do so many things. What they do is actually they spend most of their time in, you know, creating a beautiful UI and all those things. But if you have to create, if you have to understand the core of the app, I think this is the best example. It's so easy. Then the registered players can set registered players, right? And then we will set it to use state, and since this will be an array, so I will set it as an array. Okay, we will call all the addresses, all the players that are part of this lottery. Okay, I think in the spelling should not be E. I'm not sure, but I think there should be no E, so that's all. Then we will have our use effect again, so that we can have our connected account. And to have that, first of all, let me have our web3. So I'm using my state prop here, and then we will have our accounts, then await. So same syntax, web3.get accounts, and then we will have our set account, so that we can set the account, right? So I'm going to select account 0 now. So once we are done with this, okay, I made one mistake here. I forgot to have my function. Sorry for that. Accounts async, right? So we need to have our async function also. Okay, let me have this site. And then I am going to call this get account function only when I have the state.web3. Otherwise, I'm not going to call it, or the accounts. And we will have two dependencies, state.web3. Now let me have another use effect. Now this use effect will be responsible for the registered players. So use effect, okay. Now this will be responsible for our registered players. So get players, then async function. Now inside this, I will have my contract state. Then I will have my players. Now I'm going to call my registered players. So let me show you. Wait, contract, same syntax, methods, all players, right? So I'm going to call all players function of our lottery contract. Now we will require one more use effect. Now this use effect will be to display all the people or all the players that are connected or who have actually participated in our lottery. Okay, so yes, let me do that. So I will create one more function, get players async. Then I will have this, and then I will have the instance of our smart contract, that is state, and then I will have the players. So those players, for this I will again use contract.methods.allPlayers function. So this all players function will return us the array of all the players who have actually participated in the lottery, right? So let me show you. So this all players, you can clearly see that this is actually returning us an array, right? Return payable. So this is actually returning us the array. So now we have our array inside our players variable. Now we need to map it. So I'm again using registered players await promise, since we have to resolve all the promises. And in this I will have my players dot map player, and then return player. So you must be wondering why I'm doing this, right? So let me show you. So okay, I will show you so that you can better understand. So let me console.log this players so that you can better understand why I'm doing this. And then let me console.log the registered players also. Okay, things like this I think it are much better to show than to explain, so that's why. set, then let me set the registered players. So we have the our registered players in our array, registered players. So I will set that. Okay. And then we are going to again call our get players function, and I'm going to call this get player functions only when I have my contract instance ready, right? So then I will call my get players function, and then in my dependencies I will have state dot state dot contract. Okay, save. Okay, so now we have our players.js ready. Let me save this also. So this is how our players.js looks. Definitely we haven't shown anything in the front end. So let me return something also. So return. Okay, now we will return the connected account. So I'm not adding the CSS for now. I will add it once I will show you the logic, a connected account. So we will have our connected account here. Then just let me have a break statement. Then we will have one more thing, that is please pay 1 ether on this contract address, and in this we will have the address that we have actually fetched from our app.js, right? So this address I'm using this. So this contains the address of our smart contract. And let me again have my break statement, and then we will have the registered players. So for that I will use registered players dot length, means if it is not equal to 0, then only I'm going to show this, right? Equal to 0. First condition is this. Second condition is that, means second condition is not the condition, actually it is mapping, actually registered players dot map name the key, because in React.js key is a very necessary thing. We should have keys, otherwise it will throw you an error. And then we will again have our name. Okay, so let me save this. Let me go back to our console. Let me see whether we have any error or not. Okay, players is not defined, saying that. Okay, I think we haven't imported players.js. Let me go back and import it. So import players from, right? Let me see what is the other error. Address is not defined in app.js 39. Okay, let me see that. So we do have the address, right? Okay, we have made one not mistake actually, but yes, so we should also set the network.address also, right? So let me set that also. So we will create one more set address, and in this we will have our deployed network.address, right? It's because we need the address of our contract, and here we will have const address set address use state null. Okay, now this is good. Let's see. So this looks good, and now let us improve the UI of this players.js. So now the UI of our app.js also looks good. So we have also corrected the UI of our manager.js, and now this UI also looks good. So now what we need to do is, now we need to create our nav bar, as well as we need to have two pages. First one will be manager page, and another one will be the players page, as we have also seen in the demo decentralized application, right? So we need those two pages. For that we need a thing called React router DOM. Okay, so we will install that so that we can have multiple pages, and then we will check the final functionality of our decentralized application. So we are very much close to complete our decentralized application. I hope you are enjoying this tutorial. So one thing that I want to say here, that creating a decentralized application is not that much difficult. You have to simply read and write from the blockchain only. Before decentralized application, we were using server in order to read and write. from the server, and now we are using blockchain in order to read and write. And if you will see the difficulty level, it is so easy, guys. It is so easy. If you want to have complicated UI, then that's a different thing. If you want to have a lot of models and a lot of dialogue blocks is appearing and a lot of animations, and that's a different story, then definitely then it will be a complicated thing. But you can clearly see that creating a decentralized application is not that complicated as it seems. So I think this tutorial it is helpful to you, and if it is helpful to you, let me know in the comment section also. And if you are confused in anything, then also let me know in the comment section. Okay, so meet you soon, and let's complete our decentralized application. So now in this video, what we are going to do is we are going to install React Router DOM. Okay, because this will be helpful in order to have different links to our pages, different URL to our pages, and you will understand. Let me first install it. npm install React Router DOM, and we will install the 5th version of it. Okay, not the 6th version. Remember, I'm going to install the 5th version. This is very important, so please be careful here. npm install React Router DOM at 5. So this is the whole thing. Do not just do not just install npm install React Router DOM. So install. So let's wait for it to get installed. Till that time, let me show you what we are trying to do here. So currently, if you will see my decentralized application, the decentralized application that I have created earlier. So if you will see, I'm able to move to different pages, right? So I'm at manager, and now I'm at player, and you can clearly see that the links of our pages are actually being changed. Means not a page of our web is actually being changed, right? So when we were at manager, it was localhost 3000 at not at slash manager, but now when we are at players, so it is slash players, and when we will go for lottery system, we are at the starting of our decentralized application, right? Starting page of our decentralized application, and definitely from here we can again go to different pages, right? So if I will, let me go back to the players. If I'm, let's say, not lottery system, players, and if I will go players, you can clearly see that it is localhost 3000 slash players. So this type of functionalities we also want in our decentralized application, and this is what I'm going to do. So now it is installed. So first of all, we need to make some changes to our index.js, because we have to tell that we are going to use React Router DOM here. So what I will do is I will do import okay, mistake, browser router. Now in order to activate this React Router DOM, we need this component, import React Router browser router from React Router DOM, this one. Okay, and now we will take this browser router and we will enclose our app inside this. So browser router, and let me cut this from here, and then let me have this here. Okay. I think everything is perfect. Okay, I think let me see the spelling mistake, because if there will be a spelling mistake, it can cause us trouble. So it is browser. Okay, we have made a mistake, right? Actually, I have made a mistake, so it should be browser, right? Now everything is correct. Now let's go back to our app.js, and inside this also import two things. First will be the route, okay, and another thing will be the link. We will use the link in some time, but for now let's just import it. React Router DOM. Done. Now once this is done, let's go down here, and in this let's again comment this out, and let's have our manager inside route. Now this is all the syntax of React.js, guys. So if you do not know React.js, then definitely it will be a trouble something, I will say, manager. Okay, and in the same way we will do for our players. So you can clearly see I'm giving the path that slash manager will be this component, and let me have another route here, route, and inside this game I will have my players. Okay, so now I have created two routes here, and let me have the path also, right? So path will be players. Okay, save it. Let's try to run this. So npm start. Let's see whether it is running in a right way or not. Okay, yeah, my old application is already running. So let me check in our new port, that is 3001. I hope it will work. Okay, so currently you can see that it is not showing us anything, right? And the reason for this is very simple, because now if we will go for slash, okay, not like that, slash manager. So now you can see that you have your manager component, right? Now if I will go, okay, again to players, so you can see that you have the functionality of your players also here, right? Okay, so now we need to do something so that we can have this starting page also, right? That you are a manager or a player, right? So we need to create this page also. So let's get back and create this page also. Okay, so now it's time to create one more component so that we can have a default page whenever someone opens our decentralized application. And for that, we will have one more component by the name of intro.js. Okay, so in this component, we will be having all our functionalities with the help of which user can switch between the two pages. Like as you have seen in my demo application, we have a manager button, we have a player button, right? So once someone's click on the manager button, then that person goes to manager page, right? And if someone clicks on players button, then that person goes to players page. Then from React, so first let me import this React, and then again, since we need the functionality of link here, okay, this is also part of React.js only. So we will have that from React router DOM, okay, and then definitely we need to, okay, let's do that CSS part afterwards. So const intro, so let me create the component here, okay, and now we will have our return statement, and inside this again we will have this, and now we will create our functionality. So the first thing first, what we require is we require a button, right? We require a button with the help of which user can switch between pages. So to do that, what we are going to use is we are going to use the link component. Okay, so in this link component, again, I will have the functionality to switch to the manager page. Okay, then we will have the button here. Okay, button, and this button will be the one which will actually help us so that we can switch to the manager. So manager, okay, in the same way we will have for the players. So this will be for the players. Okay, let me write players here, players. Okay, and definitely you can also add that line that I have in my uh, in my in my decentralized application, that you are manager or what. Okay, you are manager or what, definitely. And now we need to do some changes to our app.js. So in our app.js, first of all, we need to import our intro. So import intro, and definitely we will take care of the CSS, right? So don't worry about it. Components, and then we will have intro done, right? Now in this we will make some changes again. We will have a route, and this route will be of exact path. Okay, exact path, and then we will have our intro here done. So this is it. Let me save this. Let's see whether we have any. Okay, we do have an error. Doesn't, okay, oh, so sorry guys, let me export this also, right? So export default intro done. I think everything is fine. Okay, we haven't used link. Okay, we will use it. Actually, I have used a link component here in app.js. I have imported this link component because we also need the nav bar, right? So we are going to use this also, so just don't worry. First of all, let us go to our application. Okay, not this one, this one. Okay, and let me reload it. Okay, currently we are on players, right? So let me go to this. Okay, sorry, fine. Definitely, we are going to improve the UI. So for now, let's just check the functionality. So if I will click on manager, so currently you can see that I am on manager page. And if I will click on players, I am on players page. So our functionality is running very smooth. Now it's time to add some CSS to it, right? Definitely, it does not look at all good, but functionality wise, it is running in a perfect way. So let's go back and let's change the CSS of our decentralized application. Okay, so now it's time to make changes to the CSS part. First of all, I will create one more file by the name of intro.css. I will paste this code here. The code is given below in the description, so you can copy paste from there. Then we need to make changes to our app.css. Now in this app.css, we will have a different code. So let me save this also. And now it's time to change how our app.js looks, right? Because currently we do not have any classes or something like that. So let's have those classes so that we can improve the UI of our app.js. Okay, in order to improve the UI, I will just copy paste this code. So this code just consists of the CSS element. So don't worry, nothing new, nothing else. Only one difference that you will be seeing there is that I have also added the nav bar here. Okay, so the nav bar in just the same as we have done the changes in our lottery, right? In the intro.js, clearly you can see that I have this link component, right? So I have used the same link component in order to have our nav bar. So simply I have link to, then this is our default page for lottery system. This is our link to for our manager component, and this is our link to for our player component. So nothing else I have done more here, and simply I have added the classes wherever that was required. Okay, now this is also done. Let's go to our intro.js and let's paste this code here, and then we will do. So now let us import our CSS file, right? We need that. So intro, and then let's check whether our application is looking fine or not. And our application is not looking fine. I think app.css is not applied here. Let's see why that's an issue. Okay, so currently we are on, I think, body tag. And in this, if you will see, currently app.css is not being applied. And let's see what is the reason for this. And this style is being applied, and I think the reason is what I can see on my screen is this extra element that I am seeing on my screen. I do not know why this is here. Let's see whether we have made some mistake. So let me go back to our VS Code. Okay, now let me go to our index.html file, and yes, I was right. There is one extra element here. I think this is the element that is causing the issue. Let me go back, and now I think everything is fine. Okay, there is some issue still there because of this, right? Let us check what is the issue here. I think the issue is, okay, yes, the issue is with because of the CSS file, right? We should have the .css extension also because it is a CSS file. Okay, now everything is correct, but still there is some issue with the buttons, right? Let us check what is the issue with the buttons. Okay, so our decentralized application is totally ready. If you will see, we have our manager, we have balance, everything is perfectly working fine. Lottery system, everything is working fine. Now let me tell you that now there is one issue that I think I made a mistake, and you should also learn from my mistake. But the issue is that now you can see that we are not being showed the connected account. We are not being showed the contract address. I am not being showed the contract address. You might be seeing your contract address as well as the connected account on your screen. And the reason is because let me tell you the mistake that I did. The mistake that I did was that first I deployed this smart contract over a test network, right? And we got this contract address, right? Now, after deploying it to the test network, what I did, because checking your smart contract, testing your decentralized application over a test network directly can be a time-taking process. So to save that time, what I did, I deployed the same smart contract over Ganache. But while doing so, what I not did was the change. I overlooked this thing that I did not change this contracts file, this contracts folder, which consists of our lottery.json file. And because of this, I got into a trouble where it was showing like in my console that I ran out of gas. Now you do not have to worry about anything here, right? We have to just do one simple change here, is that we need to again deploy our smart contract on Ganache. So this, there is no problem in the decentralized application, there is no problem in the smart contract. The only problem was that we did not change, actually I did not change this contracts folder while I was redeploying our smart contract over Ganache. So to avoid this situation, like now since we are in this situation, because now you might have done the same as I was doing, so to avoid this situation, what we can do is we can again deploy the smart contract, and that's an easy process. I think now you know this also, but before deploying it, just remember to delete this .json file. I think otherwise if you will not delete it, again it will give you the same issue. So I'm deleting it. Okay, now it is showing that okay, we do not have a lottery.json. Definitely there is no lottery.json. Now what we will do is, again I'm going to deploy the smart contract. Okay, so okay, we do not need to go to the client, right? So let me just clear this, and now I'm again deploying the smart contract. Okay, so everything is correct, just the deployment thing was wrong, so I'm again doing that so that we are not stuck in this issue. And if it work fine, you will see again all the things will start working. Okay, so now again our contract is deployed, and now let me check the contract address. Where is the contract address? So this is the transaction hash, and this is the contract address. So this is the contract address of our new contract. Okay, let me go back. Okay, it is saying that we do not have a lottery.json. Okay, let me see. I think we do have lottery.json, right? So okay, what is the issue here? I think there is no issue. Let me again run this application. Npm start. I think this will actually work fine and will not have any issues. Let me close this. Let me go to manager. Now you can see that we have our connected account. If we will go to our player, so we have our contract address as well as we have our connected account. So as I said, there is no issue in that. This was an important issue, I think, that you also should know. So I made a mistake, and you can learn from my mistake, that when you are doing this type of thing, remember to change the lottery.json, like delete the lottery.json, so that once, let's say if you are deploying it to the test network and you are deploying it to the Ganache, in that case first delete the lottery.json file that you already have in your contracts folder, and then only do the smart contract deployment on Ganache. Okay, so remember this thing. This is, I think, a key point that you should remember. So let's do this again. Let me register the players once again. Okay, so now to register the players again, we will do the same thing. The only difference will be that I will have this contract address this time, and then I will send this to one ether, right? And then next, so this will be a registered player. Okay, so this is our registered player, right? Let me refresh it. Definitely we will call this issue, we will resolve this issue also, because we do not need to again and again refresh the page, so that we have our registered player list. Okay, let me select some other account. So let me select account 41. I think account 40 is our manager, so I will not select that. I will connect this. I will again send, paste the account address. Next. Okay, I think made a mistake. Let me reject this, because I haven't given one ether here, right? Then next, and then confirm. So let's wait for our transaction to be confirmed. I think it is confirmed. Yeah, it is confirmed. Let me refresh it. So now you can see that we have another registered player, right? So now let us do one more, so that we have at least 3 players who can participate. So again, I will select one of different account. Let me select this account. I will click on connect. Let me refresh so that we are connected here. And now what I will do is I will send one ether again to our contract address. Next, confirm. And now if you will see, in some time when our transaction will get confirmed, so we will see a third address also here who has like participated in this lottery. So now you can see that our decentralized application is working absolutely fine at players end. Now we have to do only one thing. We have to go to the manager end, and now what we will do is we will check the balance. So since we are not the manager, right? You are not the manager. That's why it is printing that. That's right also, because we are not the manager, right? The manager is the account number 40, right? So I will go to account number 40, who is actually the manager of our account, of our contract actually. And then I will again click on click for balance, and now you can clearly see that we have 3000. Okay, the thing is, it is actually being shown in way. So what we can do is we can either change this at 2 way so that we have a correct amount here. So this is actually 1 ether is equal to, I think, 10 to power 9 way, or as far as I'm remembering it, one thing is for sure, it is in way. So that's not a problem, we will check that. So what's the issue here, but this is for sure that this is actually in way. So what we can do is either we can change our front end to way, or we can use web3.utils library in order to change it this way into ether. Okay, we can do that. Now let me click for winner, and let us check one thing so that we are sure also. Okay, okay, we do not need to do anything. Let's click for winner. Okay, we can directly do that because it will show us the winner here, right? So I will click on confirm if everything will work fine, and here it is. So this is the winner of our lottery smart contract, and our decentralized application is working absolutely correct in a perfect way, right? Now we can check the balance of this account. So we can either check in Ganesh. So if we will go to A380, now you can clearly see that he has a balance of 101 ether. So 2 ether has been transferred from the contract balance to his account, and we can also check the contract balance once again, and you can clearly see now it is 0 ether. So it shows that from contract balance, ether has been transferred to this account. And also let us check the players array. So you can clearly see, since we at the end of our smart contract we have erased our players, right, array of players. That's why you can see that we do not have any account addresses now, because now our players array is again empty, so that we can again start this lottery smart contract process. Currently our decentralized application still have one problem, and the problem is that, let's say if we are changing the account, right? So let's say if I am going to my Metamask wallet and I'm trying to change the account. So let's say I have selected some different account. Okay, but still this account is not being reflected here, right, on our decentralized application. In order to reflect this account, we need to refresh our page, and then only you will see that we have our new freshly connected account, right? So how we can resolve this? We will resolve this also in our player.js, because in this also you will see the same issue. If I will change the account. Okay, so let me select this account. Still you can see that it is 0842, but still it is not changed, right? We have to refresh here, and then only we can change the change account. Okay, so let us improve this functionality. So to improve this functionality, what we are going to do is we are going to use a set account function, set account listener function, actually set account listener, and this is something provided by Metamask. Okay, so it is not something related to your web3.js or related to your React.js. This is the function which is actually provided by your Metamask wallet, so that you can have the functionality that we are looking for. So we will have accounts changed, okay, and then we will have a comma, and in this we will have our accounts, and in this then we will have our set account function. We will call our set account function to set the account. Okay, so what this function will do, it will automatically select the account when we will change any account in our Metamask wallet, and you will understand. Let me complete this. Now we need to call this set account listener function also, right? So we will call this in our get account function when we are actually setting our account here, right? So I will call this here only. So set account listener, and here web3 dot provider. Okay, so this is done. Let me copy paste this, and let me paste this to our players.js also. Okay, so I will copy this and I will paste it here, and again I will take this set account listener and I will paste this here. Okay, so let's save this. Okay, I made a mistake. Let me again go to this and paste this, save and save. Now let us test our decentralized application once again. So okay, so there is some issue. Okay, I think we have made some mistake. Let me go back. Okay, the mistake that I did is here. It should be given provider. Let me make the changes to our players also so that it's not have to save. Let me save it. Let me go back. Let's hope it will work fine, right? So let me now change the MetaMask account so that we can check whether it is working right or not. So let me select this account and you can see here, right? So as soon as I'm changing the account, we have a different account on our connected account, right? So this is good. Let us check this on our players.js also. So I'm going to MetaMask. Let me change the address to this and right. So it is working perfectly fine. Okay. And now let us improve the functionality of our players.js component, where when some player wants to register, let's say if this player wants to register, so I will copy this address, contract address, I will go to my MetaMask and I will send Ether to this address so that I can participate in this lottery, right? So I will have one here and then I will click on next and confirm. So now let's wait for our transaction to be confirmed. And our transaction is confirmed, right? But the problem here is that I have to refresh this page so that I can have my registered players, right? And we do not want that type of functionality in our decentralized application, that we have to refresh our page again and again so that we can see the registered players. So let's make some changes to our players.js component. So we will make one more use state, that will be reload use state. So this will help us in reloading the page, okay? Reload, set reload, and initially it will have, let's say, false. Okay, so initially it will have false. And let us create one function, const reload effect, and then inside this we will call our reload, means we will set the state of this use state by not of reload. So what we are doing here is we are toggling the use state, right? But if reload is true, then we are making it false. If it is false, then we are making it true. And you will understand why I'm doing this. So I will go to my use effect of our registered players. Where it is? This is our get players, right? Now once we have registered our players, what we will do is we will call this reload effect. Now, once we will call this, toggling will take place, right? And then we will have our reload in our dependency list. Now this will make sure that when some player is registering for the decentralized application, not for the lottery application, in that case we will see the address as soon as he will register. Okay, we do not need to refresh, we do not need to do anything, and we can do that just by using this reload effect function. Okay, let's see that. So going back, and now I will again select this address and I will select some different account. So let me select this account right now. Nice. Send account, let's say some one ether, next, and confirm. Let's see whether our functionality is working or not. So once this transaction will get confirmed, we will see registered players here, and here it is, right? So I think now our decentralized application is working absolutely fine, absolutely correct. Definitely there is a lot of scope in this to change, right? You can make a lot of changes here. You can make changes to the CSS as well as other changes as you wish. Like one of the changes that you can do here is that you do not want that the same player participate in the lottery twice, right? At this point of time, we do not have any functionality in our lottery smart contract which can prevent from this happening, right? Because this player can re-register for this lottery again and again, right? So if you want, you can have that type of functionality also. Definitely there is a lot of scope in for this decentralized application to get improved. So feel free to do that, and also let me know in the comment whatever things you feel that we can change in this decentralized application. That will be very helpful for me as well as for other students as well, right? Now let us again deploy our smart contract over a test network. So let's again do that because we till now we were doing everything on Ganache, right? So let us again deploy our smart contract over test network. And for that, so do not do the same mistake, right, as me that I have done before. So for that, first of all, we will go to our contracts folder. We will have this lottery.json, and definitely if you want to copy this, you can have this in your folder. So let's say if you want to again use Ganache, so we can copy this also. Let me copy this so that I can have it, and I will use it when let's say in any point of time when I will require it, right? So I can copy this. I will save this. Let me make one text txt file, right? Let me make some txt file here, and we will have that. Okay, let me paste it here in this area. Okay, so let me have this txt file just to, you know, let's say if in future you want to again test your smart contract on Ganache, right? So you can do that. For that only we will have just here, and then we will delete our lottery.json, and then we will deploy it on the test network. So now we will have this as a backup. So if something goes wrong, we will again have this. Let me delete this. Okay, and now let me migrate it over a test network. Now before migrating over a test network, remember one thing: make changes to your Truffle config.js, right? So first of all, comment this out. We do not require it now because we are going to deploy it on the test network. So let me uncomment these things, right? So let me uncomment these things. So we will require these, and then we will require our Gorilla testnet. So for that, where it is, I think here it is, right? So I will comment this out also. Okay, the whole part. Okay, made a mistake. So I will comment this whole thing again, save it, and I think we have done all the changes, right? So we have our SD wallet provider, we have our Alchemy key as well. So let us deploy it on the okay, it is saying that it is not finding the JSON file, and that's true also because we have deleted that lottery.json, right? So let me click on yes, and now let us deploy this once again over a testnet. So let me go back one folder back, and then we will do Truffle migrate -- network, and then go LE, right? Spelling. Now let us wait for our smart contract to get deployed on the testnet. Wonderful. So our smart contract is deployed to the testnet. Now let me again run our decentralized application client, right, and npm start. Let's see whether everything is working fine or not. Okay, wonderful. So it is saying that it is failed to load to Web3, and the reason for it is because we are still connected to Ganache. Let me select Gorilla test network from here, and then it will not be a problem, right? So I hope you have enjoyed this tutorial of decentralized application. We have learned so much, right? We have learned how to create a page in our decentralized application, how to navigate in our decentralized application, how to have different type of functionality in our decentralized application, and how to use Metamask API in order to change accounts and each and everything, right? And do check out Alchemy Web3 tutorials, where they have explained each and everything about creating decentralized application, NFT marketplace, or let's say how to, you know, link with Chainlink. So you can see that here also. So they have a lot of tutorials here for Web3 developers. Have a look at this so that you can also learn about NFTs, DeFi, and other things as well. Okay, I will share the link in the description so that you can have a look at it.